Welcome to another Godot tutorial video. Today we're going to look at loading scenes in a thread in the background. This allows us to load a new level without the interface freezing up as the game waits for resources to load from disk. We will be doing this for VR, but everything we talk about here can be adopted for normal games as well. Before we start, we need to download a script we can find on the tutorial pages. This script contains a bunch of control code that helps us in loading resources. I've already prepared a new project. I've added both the OpenVR and VR Common add-ons, a few textures, our resource loading script, and an empty main scene. For the add-ons, I recommend getting the latest versions from source, as they contain various bug fixes. Our first step is to make our resource loading script available. We go to our project settings, go to the Auto Load tab, select our script and add it. This makes our script accessible throughout the game. We're going to use our main scene as a sort of construct. It will contain the elements of our game that are always available, but the rest will be loading in as we need them. Let's add the things we need in, and then start making it all work. First, I'm adding a color rect. As this is a 2D object, it will be drawn on top of our 3D scene. We'll be using this later on to black out our screen as we transition. Next, we'll add our VR FPS subscene from our OpenGL add-on. This is where VR is different from a normal game. Because we want to be in VR from the start, we need this in our main scene. In most normal games, the levels you load will have their own camera setup. We'll also add a spatial node for our loading scene. This is the scene the player will see while we are loading a new level. Finally, we add a spatial node as an anchor point for the scene we're loading. We'll hide this node for now. Now comes the bit we've done 100 times before. Let's get our VR initialized. Just to separate things out, I'm adding a script to our player node. Then we find our OpenVR interface and we initialize it. If we're on an older build of the plugin, we need to turn HDR off. On the newer versions, you'll need to turn Keep Linear on. Alternatively, you can use the Glass 2 driver, but we're using Glass 3 today. We turn VSync off, seeing our HMD will render at a higher frame rate than our monitor. And we set our physics update to 90 FPS. Finally, I almost forgot the most important step. We need to set the AR/VR mode of our viewport to true. The next step is dressing up our loading scene. This is the environment the user will be in while we're loading a new level. It will always be available, but we'll hide it when we don't need it. As such, we're going to set up the default environment and use it for our loading scene, and then override that when a level is loaded. We'll keep our loading scene simple, and thus we want a pitch black background. We simply change the background mode to a fixed color. Even if we disable teleport or direct locomotion, a player can still physically walk around in VR. We're going to cheat here by making our scene so large it won't matter if the player walks a few meters forward or not. All we're going to present here is a large plane with our splash screen on it. We add a mesh instance and set up a quad mesh. We'll make it nice and large and configure a material with our splash screen as an image. We also need to turn shading off, seeing we don't have any lighting, and we turn transparency on. Then we move our mesh instance back. We also save our node as a subscene. That makes it easier to work with later on. The advantage of this setup is that the user will still get proper visual feedback when they move their head while a new scene is loading. I do highly recommend adding more to this to make it more visually entertaining, but this is good enough for our purposes today. Seeing we don't want to suddenly switch between our loading scene and our real scene, we'll want to add in a fade out and fade in effect, switching between them. We do this with the color rect node we added. Again, I like to keep things organized, so we'll save our node as a subscene. We also add a script to our subscene. We'll implement it in a minute. We change the color of the color rect to black. And then we increase the size to ensure it will always be larger than our display. Let's implement our script. We start by defining a signal. We'll emit this signal when we've finished fading in or out. Next, we define an export variable which determines whether we want our display to be faded in or out. This will drive our animation. I add the basic setter and getter code in for now. We also define an export variable that tells us how long we want the fade in or fade out to take. And we add a variable that holds our current alpha. In the setter function, I'm also setting process to true. This ensures that our process function gets called. This will be on by default on our script, but we'll be turning it off every time we finish the fade in or out. Now for our process function, we first check if we're fading in or out. If we're fading in, we're checking if our alpha is smaller than 1, and if so, we increase our alpha. If it is not, we're turning our process function off and emitting our finished signal. If we're fading out, we do exactly the same, but now decrease our alpha until we reach 0. Next, we update the alpha of the color of our color rect. Finally, we make our color rect visible only when we're not fully faded out. The final thing we need before we can start tying this all together is a scene to load. I'm going to start by creating a base scene from which we'll inherit all scenes that we load into our game. We'll add a position node to our scene. This will be the location within our scene where we'll move the player to. We'll also add a world environment node here. Then we save this scene and add a script to the scene. We don't have anything more here for now, but we'll be extending this as time goes on. To create our first test scene, we go to Scene and select New Inherited Scene. We now select our base scene. We select our World Environment node and create a new environment for our new scene. I'm going to use our procedural sky here for now, so we'll change our background mode. Our player has to stand on something, so next we need to add a floor. We start with a static body and add a mesh instance as a child. Under mesh, we add a new plane mesh. We resize the plane mesh to make it nice and large. I always subdivide these out of habit. I don't think it's really necessary. Now we add a new spatial material to our mesh instance. I'm assigning a simple grid texture here. We do need to increase the UV scale to make it tile. To make the floor work, we also need a collision shape. I'm using a box shape here instead of a plane shape like I did in other videos. This is recommended these days, though I'm not entirely sure of the reasoning behind this. If someone knows, please comment below. We make the box nice and large, but keep it 1 unit high. We move it down so the top of the box is nearly flush with the floor. I leave a little bit of space so we don't get clipping issues with the floor. This definitely will require more tweaking later on. Let's save our scene and place it in its own folder. I want to have objects in the scene cast shadows, and for that we need a proper light source. Let's create a directional light and align it with the sun in our procedural sky. As our scene is now lit both by our directional light and our very bright sky, things are getting a little bright. We'll go back to our environment settings and decrease the contribution our sky gives to our ambient lighting. Let's add a few boxes into our scene. We'll start by creating a rigid body so that we can interact with the boxes. We add a mesh instance as a child and create a cube. We also need to create a collision shape to match. We'll save our cube as a subscene and then duplicate our node a few times so we have a few boxes in our scene. As we currently spawn in the middle of our stack of boxes, I'm moving our spawn point away. So now it's time to start joining the dots and make this all work. We implement our logic for switching and loading scenes in our main script, so let's edit that. First we initialize a variable and point it to our auto-loaded script. We simply get the node Godot has exposed on our root. Then in our ready function, we need to initialize our resource queue. Loading a new scene is a process we do in a number of stages. To help us with this, we're going to add an enumeration. First, we want to fade the screen to black so we can remove our current scene. Next, we make our loading scene visible and fade back to transparent. Now we wait while we finish loading our new scene. Then we fade to black again so we can hide our loading scene and add our new scene. Finally, we fade back to transparent so our new scene becomes visible. The last state is the one we'll be in while our scene is active. We add a variable that tracks the state we're currently in. And we add a variable that remembers the scene we've currently loaded. Finally, we add a variable that tells us which scene we're currently loading. Now we add a function that we can call to start loading a new scene. This function stores the scene that we're loading and then tells our resource handler to background load that scene. We then change the state to our first fade to black state and tell our color rect to fade to black. Our color rect now needs to communicate back to us once it's finished, so let's hook up that signal. There are 4 conditions on which we finish our fade. We'll add everything in sequence. Let's add a match statement in and check for our first state. The underscore section is the match for anything we've not specified. We start by hiding our world scene, which we can safely do as our screen is now black. Now we can remove our current scene. We remove the node first and then free it. Next, we want to reset our player's position. For this, we'll write a method on our player script, but we'll write the code for this after we're done with our state changes, so for now it's just a stub. Now we make our loading scene visible. And we fade back to transparent. Once this fade completes, our finished fading signal is emitted again, and we can check for that condition to come in. Here we just change our state to loading. As we'll be handling the next step in our process, we set process to true. In our process method, we check if our state is indeed loading. We'll look into showing progress another time. If we are loading, we call our getResource function on our resource queue to see if our scene is available. It will be null if it hasn't finished loading. If we have loaded it, we instantiate a new scene and assign it to our current world variable. Then we fade to black and turn our process function off. When our fade to black finishes, our signal is emitted again, so we implement the next bit there. Now that our screen is black again, we can hide our loading scene. Now we add our new scene to our scene tree and make our world scene visible. Once we can see our world scene, our finished signal is emitted again and we simply change the state back to plain. Now we can call our load world for the first time. We want to have control over the location and orientation of the player when our scene loads. This is why we added the spawn point to our scene. We need to call our position player method once our scene is loaded, but we skip that step. We could add it in our main scene just like we reset the location when our loading screen becomes visible, but a better way would be for the scene we just loaded to handle this. This allows us to perform further actions once the scene has been added. So we're going to implement an initWorld function, but we're going to add this to our base class. We're going to remember our player node as we'll want to interact with it frequently, and then initialize our position. Note that I am using type GGScript more and more often. Not only does it help Godot find mistakes early, it also clearly documents what we expect here. Now we can call our initWorld from our main script. This all won't work unless we implement the position player method, so let's implement this. We start by obtaining the global transform of our player's camera. We remove the height. And then we use a bit of funky math to remove whether the player is looking up or down. We only want to keep the direction. Now we inverse the camera's transform. Applying this to our origin node would make the player stand in the center of our scene. But we want it on our position, so we combine our inverse camera transform with the transform we want and apply it to our origin node. Ooh, I made a typo at the start, so we'll quickly correct that. And the final calculation was the wrong way around. Oops. Well, that was pretty quick. Our scene doesn't take long to load, but it does show things work. Let's dress things up a little more. In order to implement interactions with the world, we need to add things like our locomotion features. But these should not be active in our loading screen, and we may not want them active in some other scenes. We'll need to turn editable children on for this. First, we need to add in our VR Commons shader cache. I've got a nice video explaining why this is required. It is very important to note that this issue persists even when you use background loading. Shader compilation will pause your gameplay, so make sure you precompile any shaders you use in your game with our shader cache trick. We'll add our teleport function to our left hand and keep it disabled for now. We also need to assign our camera. On our right hand, we'll add our direct movement, and we also disable this. Next, we'll add our function pointers to both hands and disable those. That reminds me, we should set up our layers or we'll get some clashes. Let's go into our project settings and define our first layer as the player layer and the second layer as our environment layer. Now on our functions, we turn layer 1 off, or our functions would interact with the player itself. Note that the direct movement function doesn't have settings and assumes layer 1 to be used for the player. We also need to update our scene and move all our physics objects into layer 2. For our locomotion, we simply enable our functions. I'm adding some handy variables here to access them. I'm also calling this from our ready function because properties are set before our scene is ready. If the pointers are active, we're only going to have one pointer active and we'll keep a variable stating which one. Then we use that when enabling our pointer. As always, I've got my equals comparison wrong. Finally, we're going to switch active pointers on button press. We hook up our button press signal on our left hand and check whether the button being pressed is our active button, whether our pointer is enabled, and whether we've got our right hand pointer active at the moment. We then do the same thing on our right hand. And that equal comparison again. Now in our main script, we can make sure both our functions are disabled when we switch to our loading screen. For our scene, however, we're going to add some convenience properties in our base scene. We simply pass our values to our player node if we have one. And then make sure we update these once we have our player node. And now on our test scene, we enable our locomotion and leave our function pointers disabled. Before we test, we need to correct a mistake. Our boxes do need to interact with our environment. We can see that we can teleport now and move around. I'm still looking into the shakiness of the teleporter. For the last little bit, I've created a new scene off camera. This is still a work in progress, but it allows me to demonstrate the last bit of this tutorial. A scene like this is what you'd often find when you load into a game. A menu system where you can configure your character, select difficulty levels, load saved games, etc. You can see 3 black quads in the scene. These are hooked up to 3 viewports that we can interact with. I'll do a separate video on how I've built those. There is an earlier version of this in an old tutorial video I did converting the Sponza demo to VR. If you're interested in it, follow the link on the screen. First, we need to change our main script to load this new scene instead of our other scene. Also, I had to implement the signals on our pointers. Note that the pointer on the left and right hand both call the same signals. The code for these signals is really simple. We duck type stuff here. We simply check if the body our pointer is interacting with has the corresponding methods. If so, we call it. Only the middle of our 3 screens has functionality on it, but all 3 do work. Note that I have a subscene on each screen childed to the viewport. This requires turning editable children on. Going into our subscene here, we can see that this is a standard 2D Godot scene. Quickly going back to our selection scene, note the script that is on the body here. This contains a bunch of code that will react to our pointer, translates that to mouse events, and sends those to our viewport. Now we can run this scene by itself and interact with it with our mouse. There is no special magic here. Before we run this in VR, however, I want to add a bit of logic. I want to load our original scene once the last button is pressed. So let's implement that. Note that I already created a script on the root node of our 2D scene. We simply hook up the 8th button. We could simply call into our main script's root node here, but that is ugly. Instead, we'll have our button emit a signal. We drop our scene in there to easily get our path. Now we can connect our signal in our selection scene. Now this still isn't the place where we can load our scene, but here I want to implement the signal definition in our base scene. And now we emit that signal from our selection screen. Last but not least, we need to hook this up so it calls our actual load world function. We connect to our signal when we've loaded in a new world. And we must not forget to disconnect when we're about to remove the world. One last thing, note that I only enabled the pointer in the selection screen. And that's it for this video. Please leave a like if you found it useful and consider subscribing to my channel. If you want to support my work, consider becoming one of my patrons. Thanks for watching. Until next time.